Hey everybody, it's time for our last chapter of the year. Yay! Chapter 11, we've already done 12. We did that, I think, with chapter 9. So we're going to go on with chapter 11. So we're starting with section 1 today, which is lines that intersect circles. So your I will statement for today will be I will identify the parts of a circle. Okay? So what you want to do is make sure that you have your notebook with you, that you have some sticky notes with you, if at all possible, and that you are ready to go. All right, so pause me if you need to in order to get started and set up. All right, so the first thing I want to do, though, now that you're back with me, is to go ahead and get these pieces of the circle, okay? So if you want, you can go ahead and draw your circle in there. It's easy if you can go find something that's nice and cylinder, maybe a Pringles can or something. But you draw your circle right here. Then you're going to draw your diameter. Remember, it goes straight across. Diameter we are all very familiar with, but I want to make sure that you remember how to name it. A diameter goes from one side of the circle directly through the middle to the other side, going straight through the center point of the circle. By the way, your circle is named by the center point. They use a symbol that looks like this, a circle with a dot in the middle representing the center, and with this center point name. So circle C is what this one's called. Your diameter goes from A to B, so it is segment AB as your diameter. Your radius, as you know, goes from your center to a point somewhere on the circumference of your circle. So the radius is segment CD, but look, you also have radius CB or BC, either one, and CA or AC, either one. So you have three different radii that we have drawn in here. The secant is a line that passes through the circle and keeps going. So it extends through both sides of the circle, okay? It is named either with the line symbol above it with the 2 points that it crosses through on the circle itself, or you can, of course, remember, name a line using a little cursive letter, as in line L. So remember, a secant goes straight through two sides of the circle. It can cut through on the very edge or straight through the middle, either one, but it continues on both sides of the circle. Then you have what we call a tangent. A tangent, remember the definition of tangent is next to. Okay, we're not talking about the trigonometry tangent, but this one is the actual definition of tangent, which means next to. Same thing here. It is a line that is tangent to a circle. It crosses and touches the circle at exactly 1 point. Remember when we talked about on a sphere or a circle, a perfect sphere circle never has 2 points that go through the same line. Okay, always 1 point. So here you have a point of tangency, is at Q, and they may ask you what is the tangent line or line of tangency, is line M, for instance, here. Or they may give you another point on this line and you can name it Q and whatever that point is called. Okay, and the last little piece that you need to know right here, you have a chord. A chord is just a line that is inside the circle. It has both of its endpoints on the circumference of the circle, and it's named according to those two endpoints. So here, for instance, a segment EF. Now, a chord just cuts through a piece of the circle, okay? It doesn't go all the way through it, otherwise you'd have a diameter. Excuse me. It doesn't continue out both sides, or you'd have a secant, all right? So that is a chord. See, diameter and radius we were already very familiar with. Today you've learned secant, tangent, and chord. All right, the next little piece I have for you is this one, where we talk about congruent circles. And you've seen lots of these out in the world, but congruent circles, they are congruent if and only if their radii are exactly congruent to each other, okay? So if you have, in this case, AB is congruent to CD, you now have circle A is congruent to circle C. And if you think about it, that's everything in the circle. The area of the circle, the circumferences of the circle, they're all exactly the same. And vice versa. If the circles are congruent, area, circumference, so forth, then you can know that their radii are also exactly the same. This comes in handy when you're trying to figure out what the radius is. Maybe you need to find the radius in order to find, you know, a volume of a sphere or the area or something like that. Okay, now we need to, let's see if I can adjust here. We have concentric circles. Now you've seen these. Concentric circles are circles within each other and they share a center. Okay, so you've seen ones like this that look like a target sign. okay? Whether you're an archer or a marksman or just like to shop at Target. Or maybe when you look in the mirror, you see your eye, you have the iris and the pupil. Those are concentric circles to each other, okay? Or you've seen them on tires on your car. Those are concentric circles because you have the tire and then you have the rim, okay? They both share the same center. All right, so let's move over here. On this side, I'm now on the left side of mine. If you have room to keep going, you're welcome to do that. Here you have tangent circles. Now remember, tangent line on a circle was a line that touched that circle right at one point. Well, tangent circles are coplanar circles. Remember, coplanar, in the same plane, that touch at exactly one point. So you may have internally tangent, where one is inside the other, but they just touch at that one point. See here, I've also put a line of tangency there. And then you may have externally tangent circles where they also touch at one point. I know mine look like they touch it more than that, but you have these two circles right here that touch at one point, the line going straight through them. Okay, so those are tangent circles. All right. Then we have, again, the line tangent to a circle. All right, the line of tangency right there. But this is very important, that you know that a line that's tangent to a circle is perpendicular to the radius. Okay? This comes in handy because if you think about it, I can now draw a line straight from the center of the circle to this tangent line way out here, and what kind of a triangle have I formed? A right triangle. I told you those things were never going away. All right, so we've got that. Okay? All right, then let's see. One more piece of information you need before we solve a couple of problems. This one is two segments tangent to a circle from the same exterior point are congruent segments. Okay, so if we start way out here at R, all right, and, excuse me, I always kind of think of this like the sun and this is the earth, and the rays of the suns kind of go out to the sides of the earth. These right here, they start at the same point. They are both tangent to the circle, okay, which remember is also perpendicular now to the radius. But these, because they start at the same point, tangent to the same circle, these are both congruent segments now, okay? That E in there is naming that center point, so I have circle E, okay? All right, we've gone through all of the little pieces that you need to know. You will need to do a little memorization in this segment and section, okay? Because you got to remember what everything means and who's congruent to whom. So you may want to run this video a couple of times, possibly. All right, we have a couple of questions here. I've used sticky notes. You don't necessarily have to, but I did. I had some room down here. It says solve for x on this one. I have a circle, and I've got two lines that both start at the exact same point at J, right? Now remember, according to this theorem right up here, two segments tangent to a circle from the same exterior point are congruent segments. So when I solve for x, how can I do that? Exactly. I equal them to each other. Excuse me again. So 4x minus 1 equals 2x plus 9, and I have 2x equals 10, therefore x is 5. And then I just plug them back in for each one of these, and I find out, because remember the question wasn't just solve for x, but tell me what each segment equals. When I plug them in, I get kj is 19 and lj is 19. Should be units. I forgot to put units on there. Sorry about that. All right, and we have one more example. It says, what is the line of tangency? Okay, on this, they may only give you the two coordinates, so you have to graph it yourself. My circles are probably supposed to be congruent. Yep, they are. They're supposed to both have a radius of 2. Sorry. My class is very familiar with my drawings not being drawn to scale. Sorry about that. Right here, we have a center at 1, 3 for T. So this is T right here at 1, 3. Has a radius of 2, so I should have gone up a little bit more. But basically, it comes over to there. This is the point you need to know. Here's the other center, which is at negative 3, 3. Once again, a radius of 2, so he comes over here. So knowing they both have a radius of 2, knowing where their centers are, where do they touch? That's the question. All right, so when we go underneath, we find out that the point of tangency is at negative 1, 3. So let's think. I started at 1 here. I had to go left 2. I went left because this is where the other circle is. There's nothing over here. And this one started at negative 3, 3, and I had to go right 2 to meet the other circle. That gave me right here at -1 and 3, since both of their centers are right at 3. So -1, 3 is that point of tangent C. The line of tangent C that cuts straight through them is going to go right through x equals -1. It is a vertical line at x equals -1. Okay? You can most definitely have other lines that are not vertical lines. You could have horizontal and so on and so forth. But that gives you kind of a preview, an overall view of what it is we're talking about, things you need to start memorizing, things that on circles, go out and find some examples of concentric circles and lines that are tangent to circles, tangent circles, congruent circles. All of those are going to be great because you're going to do a project at the end of this year where you take pictures of things like that, so you might keep that in mind. But make sure you have your examples written. We will practice more of this tomorrow in class. And of course, or at least on Wednesday, not sure when you're watching these, we'll do these, apply this knowledge in class on Wednesday after your STAR exam, which, by the way, good luck on. All right, y'all have a great time doing your math. Make sure if you have any questions to write them down. Okay, you're welcome to email them to me or Miss Scott, and we will try and go over them in class. All right, so have a great day. Let us know if you have any questions, and we will see you tomorrow.